you very much, Dr. Huang, for the invitation to come and speak on artificial intelligence and sustainable development. This is going to be a series of lectures that I'm going to give. The second lecture will be based on my recent book on the algorithmic problem in the governance of AI. And then the third lecture will be on the balancing problem in the governance of AI. And we are going to have very, very, very interesting engagement as we move forward. As Dr. Huang has indicated, I did a PhD in AI between 1997 and 2000 at the University of Cambridge. And thereafter, I went to the lab of Professor Philippe de Velde as a postdoctoral fellow at Imperial College. So I have seen, witnessed quite a tremendous transformation of this technology from the time when data was really, really scarce and computational power was obviously quite limited to now when we can be able to build large language models that can be able to create long sentences, something we couldn't do before. We could create sentences, but they were just not long. Now, my talk is going to cover the following 4 aspects. The first one is just to explain what sustainable development goals are. The second one is how AI can be able to accelerate the attainment of sustainable development goals. And I will obviously go over how it can be applied in various areas that are quite relevant to sustainable development. And then the third aspect, we'll talk about how we govern this technology. It is clear that we need to govern this technology. The Secretary General has done his part through the high-level advisory body on AI. The Biden administration also sent an AI governance framework to the General Assembly, which was also adopted. The government of China also sent the AI governance document to the General Assembly, which was also adopted. And then lastly, I will talk about how we can be involved. Many of you here are already involved in what we are doing. Now, what are sustainable development goals? In 2015, the United Nations adopted sustainable development goals. And these are 17 in number. No poverty, zero hunger, good health and well-being, quality education, gender equality, clean water and sanitation, affordable and clean energy, decent work, economic growth, and so on and so forth. There are 17 in numbers. And these goals were adopted, there were a set of goals, key performance indicators, which were intended to be achieved by the year 2030. These key performance indicators are 169 in numbers. And just 1.5 years ago, we went to New York to the SDGs Summit, the Sustainable Development Goals Summit, where we were evaluating halfway between 2015 and 2030, how far have we gone in achieving sustainable development goals? Unfortunately, the scorecard was not looking good. Only 17% of the 169 indicators were on track to be met. The rest, we were either worse off than we were in 2015, or we were tracking way behind targets, which means we are not going to meet them. Now, the question is, what needs to be done to be able to solve this issue? Of course, there are political things that ought to be done. But I think technology, the implementation of technology, and in this particular instance, the implementation of artificial intelligence can actually help us to be able to accelerate the attainment of sustainable development goals. And I have to also make a qualifier that I actually view technology in general. That yes, artificial intelligence is the flavor of the moment, but there are many other essential technologies, whether it is biotechnology, whether it is technologies to ensure that membrane technologies for clean water, critical minerals to be able to create the necessary infrastructure for renewable energy and so on and so forth. So it's actually technology broadly. But as an expert in AI, I am going to pay special attention to how AI can be able to do this, putting an emphasis that this is just one of the many instruments that we need to enact in order for us to be able to attain sustainable development goals. Perhaps I will just start by talking about AI. AI obviously is a technology that helps us make machines that think, act, and interact using mathematics and coding. And there are many types of AI. The dominant type of AI today is really neural networks. You can call it deep learning, whatever you call it. It is really neural networks that has been dominant. But it is not the only type of AI that is available. You do have computational intelligence, you do have fuzzy logic, and so on and so forth. But those ones do not necessarily exploit the abundance of data. They are sometimes very, very difficult to scale up. So the combination of access to data and access to technology, computational technology, with all its complexities of the infrastructure of semiconductor infrastructure and how you create that, the issues around data centers, whether you run some of these things from the cloud or from the edge or embedded. The choices that you make determines what kind of AI you can be able to do. You probably cannot embed too successfully a deep learning architecture, but you can certainly run it from the cloud. And then there are latency issues and so on and so forth. Very, very important. But broadly, AI can be used to do three things. It can be used to predict, and we will talk quite a great deal about how it can be used to predict in this talk. It can be used to cluster. Most of us will remember K-means algorithms to be able to cluster. It can be, we have generative machines, GANs, generative adversarial networks, where at least you can be able to use it to create things that did not necessarily exist. But I also have to be very careful, because AI does not create information that does not exist, because it is based on some training data that exist, some model that you have all sorts of, you have priors, you have likelihoods, you have data, and then you can be able to get the posterior and make sense out of this. So this technology has been quite powerful. And I'm just going to talk about the work that we have done in AI in order to deal with SDG number 3. SDG number 3 talks about good health and well-being. It's the work that we did, and it was published by +One, on using AI to be able to understand the spread rates of COVID-19 in South Africa. And we wanted to predict the peak time, and I'm not lying, we actually predicted it quite well. And when you come to any form of infectious disease, there is an old model that can be represented as an ordinary differential equation. And I'm not going to get into the technicalities of ordinary differential equations because I want to keep this as general as possible. It's called the SIR model, susceptibility, infection, and recovery. People who are at risk, then you have infection, then you recover. And then you have two parameters that define this model. And these are the parameters that define this model, the alpha and the mu. And of course, we were able to use Bayesian statistics to learn these parameters so that we can be able to predict when the peaks were going to happen. And I must confess, this was quite accurate prediction on when this was happening. The advantages of using Bayesian, the Bayesian approach to AI actually gives you the opportunity for you to be able to predict the confidence intervals. And that is why, in addition to the prediction themselves, you have bounds that tells you how confident you should be on that prediction at that particular time. And it is clear here that it is fairly accurate here, closer to the observations that we see. But as you move away from that, which means you are predicting what is going to happen in 4 months' time, then it starts becoming quite difficult. And this is the general issue, that for any form of prediction, your confidence levels tend to be higher, closer to your observation. If you are predicting at daily temperature, you can be able to be much more confident on what is happening tomorrow than what is going to happen in 5 months' time. That is just the nature of how these things are. Now, just on the same, good health and well-being, and I'm going to add to that industrialization. This is the work that we did quite a number of years ago in developing an infrastructure called an artificial larynx. Actually, we have a US patent, and I actually just learned that we also have a Chinese patent on this. So basically what you have here, you have a device. Now you can even have a less invasive device. You have this device that basically just track the movement of the tongue. Then based on the movement of the tongue, you can generate data. Based on the data that you have generated, you can be able to create a neural network artificial intelligence model that will be able to relate the data of the movement of the tongue with what a person is saying. Why do we do that? We have people who lose their voice boxes because of cancers, and they can no longer speak. They can still move their tongue, so they can attempt to speak. So just by the movement of the tongue, in many ways, we can be able to predict what they were about to say. Another one, which is specifically on good health, is insurance. In general, here, what we are trying to do is to use AI with missing data. This is very important, to be able to calculate insurance premium. And I think I need to underline the issue of missing data, because the whole dominant paradigm of AI today assumes that there is plenty of data, that such plenty of data, it does not have any faults, which is not true. It has lots of faults, wrong measurement, difficult problem to solve, missing measurement because one of your sensors has failed. You can say, oh, maybe you should have twice as many sensors to deal with that, you know. But if both of them fail, which is likely but less likely, you know, again, you can be able to deal with issues of health and you know. And of course, this is another work on AI. How can we use AI to be able to predict the water demand? Very important, especially now in an era where climate change is making our environment drier. There used to be a very interesting type. It's still there, but it is losing a little bit of relevance now. Or maybe I shouldn't say that. Support vector machines. Here we're just comparing artificial neural networks, which is really deep learning, and support vector machines for water demand time series forecasting. Very, very important topic to deal with. SDG number 6, clean water and sanitation. And then, of course, SDG number 13, climate action, affordable and clean electricity, energy. And here we were just using AI to predict wind speed forecasting. And of course, why do you predict wind speed? And just a few hours ago, we were talking about, I was hosting the king of Lesotho, and we're talking about Lesotho being a water and energy superpower because it is at least 1,800 meters above sea level, and plenty of water from the snow that comes out of that, and because of its elevation, loss of wind. So wind prediction is quite important, especially when you are identifying places where you can be able to put wind farms to be able to do these things. Over time, there are lots of changes, and you can be able to, and we were using this model to be able to make predictions. And of course, the predictions can be for planning purposes, but it can be for how do you orientate your solar wind, and you can even add the directions of the wind and so on and so forth, and maximize the harvesting of energy from wind. Now, if we move to the issue of decent work and economic activities, I have been particularly fascinated about, and hopefully in the future, we are going to talk about how AI can be applied to the issue of finance. I've been very, very interested in how AI can be applied to the issues of finance, whether it is options and derivatives, whether it is financial forecasting, whether it is customer churn forecasting, whether it is credit scoring, whether it is to individualize demand and supply, whether it is to deal with the concept of information asymmetry, where when you make decisions, sometimes you don't have all the information, or one party has more information than another. How do we use AI to make information much more evenly available for people? This actually has huge implications on the old theory of the efficiency of the markets. Markets are not efficient because of information asymmetry. I'm sure the economists here, they will know that. Because you always have somebody who has more information than another, and then, of course, they're going to exploit that information asymmetry to make a trade, and that is not good for the markets. And, of course, the issues of behavioral economics and finance, very important topic, becoming less important now because the behavior is no longer the behavior of a human agent. It's a behavior of a human AI agent. And very, very important. And soon I would I would look forward to giving a talk on AI and economics about some of the excellent work that we have done on this subject. AI can be used to predict the conditions of structures. And here is a make-up bridge in my own country, Johannesburg, my favorite city, where I have where I live, and this is what happened. It was a temporary bridge that was created because they were building a new bridge, and you have AI technology, and we have spent quite a great deal of work. You can be able to monitor structures by measuring the vibration of structures like this. And after you have gathered a huge amount of data, you can be able to form probability distribution functions, posterior probability distribution functions. And once you have posterior probability distribution functions, you can be able to detect when a bridge is now vibrating outside the spec. And of course, and intervene, remove people. Here, 3 people actually died. Maybe block the road so that you can save life. Maybe you can use it to simulate and construct much more resilient structures on the simulation part, AI-enabled simulation. And I think this actually directly contributes to SDG number 9, industry, innovation, and infrastructure. And then one of the work that we are proud of that we have done is the issue of, we actually built a neural network in 2007 that learned how to bluff. It could bluff. It was featured on the front page of New Scientist. And of course, you can reverse it. It was bluffing. If it can bluff, can you be able to use AI to detect fraud, for fraud detection? And for intruder detection systems in our networks to prevent the proliferation of viruses, for example. And yes, you can be able to do that. This can contribute to SDG number 16, peace, justice, and strong institutions. And then we live at a time when tremendous amount of people are experiencing conflict. And of course, conflict is not something that you can just use technology to prevent them. There has to be the political work. There has to be the human dimension that comes into place. And as we are thinking of using AI for detection and prevention of conflicts, we need to be thinking about AI's, human-centric AI systems. How do you infuse the human dimensions on this problem? And of course, you can now use structured data, trade between 2 countries, distances between capitals, militarization, asymmetry between countries, levels of trade. And I can say this now because I firmly believe in free trade. Free trade is good for the global economy. And in our work here, which is in this book, Militarized Conflict Modeling Using Computational Intelligence, and also if you are from the People's Republic of China, simplified Chinese translation of the same book, we identify that the amount of trade between countries is a good indicator of the levels of peace between countries. So trade is not only an economic objective. Trade is also a peace-building objective. And I think this is very, very important. We need to have an integrated approach. Trade, peace, commerce, and development all are combined together to be able to deal with the issues that we have to deal. And of course, this contributes directly to the SDG number 16, peace, strong institutions, justice, and strong institutions. Now I'm going to talk about large language models. And of course, I would talk about two, maybe three dominant languages: Mandarin, English, and Hindi. You can be able to generate huge amounts of data in these three languages. You just have too many people who speak these languages. So they are a high resource languages. Just wanted to define the low resource languages. So you will have huge amounts of information on the internet that are written in English that you can use to train your language models. You will have huge amounts of information that is published in Chinese that are written, that are in the digital space. You can be able to create AI systems based on this. You can have huge amounts in Hindi. And then you might have mid-range languages, you know. I would even put Arabic as high resource languages. Lots of people speak Arabic. I will also put Spanish here. Then you would have depending on the number of people who speak the languages, French. And then you have at the lower level, my own language, Venda, which is only spoken by maybe 1.5 million people. You cannot be able to build huge amounts of data to be able to build large language models. So what do you do in a situation like that? The number of things that you can do, one of it is to synthesize data, synthetic data. And UNU Macau has published the guidelines for synthetic data, making data to augment data poverty or scale poverty, and here low resource languages. And in my language, but it's still not a good thing. It's not the perfect thing. Maybe you can augment using another AI technique called transfer learning, saying, well, there are languages that are close. In fact, if you go from all the way from Kenya to South Africa, these languages are actually quite similar. So how do we aggregate the data set so that we have enough information to train large language models? How do we govern that when we have created these systems so that the people who use that know the limitations and so on and so forth? And this obviously can contribute to peace, justice, and strong institutions. Another one on life on land, which is the detection of floods. We are now getting huge amounts of flooding around the world. And of course, you can use AI to be able to do this. And then, of course, prediction of platinum prices to deal with issues of life on land. And I have talked about peace and strong institutions when AI now interfaces with international relations, which is a very important dimension of my job as Under Secretary General and so on and so forth. Now, coming to the end of my talk, I've talked about many, many good things that AI is able to do. But AI also has huge amounts of problems. It has huge limitations for low-resourced languages. It can be weaponized and disrupt peace and security. Algorithmically, it can discriminate. It can do all these bad things. Now, what do we do? It needs to be governed. Now, when we say we are governing AI, what do we mean? We mean we are governing the data, the algorithm that is going to use the data, that will be trained using the data, the computational infrastructure, including semiconductors that are used to train these models and store the data and so on and so forth. And the applications, whether it is the applications in water and so on and so forth. So in other words, governing AI is complex. Governing AI in health is not the same as governing it in transportation. Governing AI in transportation on land is not the same as governing AI in transportation by flight. You know, so you have this ecosystem of data, algorithm, computing, and applications, and many, many applications that needs to be governed. And when you govern it, and I'm going to speak as a mathematician now, you are minimizing the risks. You can never eliminate the risks of AI. In fact, the only way you can minimize the risks of AI is not to use it. Once you use it, there are always risks. So you want to minimize the risks of AI while maximizing its benefits. And for those of you who are mathematicians, you will say, oh, this is a multi-objective optimization, and now we have to deal with the Pareto optimal frontier. But where at the Pareto optimal frontier do you actually place your governance model? Well, it turns out that it depends on who you are. What are your values? You know, certain countries are more risk averse. Certain countries are more opportunity seeking. It's just what you prefer, and so on and so forth. But how do you govern AI? Firstly, there must be values that govern AI. What are these values? Transparency, security, and so on and so forth. As the United Nations, we say our values on the governance of AI are directly extracted from the Declaration of Human Rights and the UN Charter. And later on, I will talk about the balancing problem, just to tell you that you can't have transparency and security at the same time. When you have transparency, you are less secure. When you have security, you are less transparent, and so on and so forth. But that is the topic of another day. Then the second part, we govern it by changing human behavior. Human behavior can only be, it's not just human behavior, but also organizational behavior. Those can only be changed through education. AI literacy courses. And here in Japan, together with Microsoft, we are doing AI literacy course. And it's not just human behavior, it's also organizational behavior. And when it is human, you have various levels of humans. You have humans who are developers of these technologies. You have humans who are owners of the companies that are developing this technology. You have humans who are users of these technologies. You need to govern it through education for responsible AI. That's what I will say is the way you govern human behavior. You need mechanisms. And in one of these talks, I'm going to talk about mechanism design and artificial intelligence, an area that I've spent quite a great deal of time, reverse game theory. And mechanisms can be incentives. What are the incentives so that we can maximize the good and minimize the bad? We need to create institutional structures. The Summit of the Future has established the scientific panel on AI. These are institutions, but these institutions are across the board. Some of them are government institutions. Some of them are voluntary institutions such as the IEEE. And some of them are universities like the UNU Hub that we are establishing at Tsinghua University. It is a constellation of these institutions and the issue of harmony. How do you harmonize them? Becomes a very interesting thing. How can we use game theory to be able to harmonize them? And they are not two-player games and so on and so forth. Policies and regulations. What are some of the standards that we need to put into place? Some of these standards will be international standards. The International Standards Organization can do this. The International Telecommunication Union can do these standards. Some of them can be at the member state, and some of them can be at the private organizations. And some of them might actually be at the technical level. What is the standard for training an AI system? When you go to an AI textbook, they will say, oh, when you train an AI system, you must divide your data between training, validation, and testing. That is a standard. Or you can say, okay, if you don't do that, you have to cross-validate. You can do it now because you have abundance of data. If you don't have abundance of data, then the cross-validation, and it can even go, leave one, leave two, leave three, leave n type of, and I don't want to get into the technicality of these things. And ultimately, it's about the laws that we need to put into place. We have been following about the AI law in the European Union and excellent elements there. We have followed the AI laws in Japan, in China. Excellent aspects. The African Union has excellent guidelines on how AI should be governed in the African continent. The AI, the continental strategy, for example. So, thank you very much.